Our workshop will be presented by Colleen Farrelly. Colleen is a data science leader whose expertise spans topological data analysis, network science, natural language processing, and generative AI. Her industry expertise include nuclear engineering, educational technology, biotech, healthcare, marketing, and ad tech. Currently, she is a startup co-founder and advisor in the Gen AI and geometry spaces. She's the author of The Shape of Data, an introduction to machine learning from a geometric point of view. In her free time, Colleen enjoys AI art contests, creative writing, and water sports. She's proud of her recent AI art contest wins, an International Haga Prize for 2022, and a nomination for the Best Science Fiction of 2022. Colleen would be presenting about Gen AI, NLP, and insights in today's workshop. Welcome, Colleen.
Let's get started. So this is natural language processing for beginners. I'm not assuming a lot about knowledge coming in here, but hopefully you will come away with an understanding of generative AI, some of the tools in NLP, and some of the ethical concerns about using these technologies. So a little bit about me. I've been a data science lead for a bit, and I also do research in geometry and NLP. I have a book that just came out, and I like to do a lot of art in my free time. So let's get started with generative AI. It's a huge buzzword these days, and let's dive into a little bit about what it is. So generative AI includes a set of algorithms that can generate images, text samples, videos, audio content, I mean, even biological or chemical structures at this point. Underlying all of these algorithms are a training sample, which is really important. If the algorithm doesn't see certain things within the training sample, if it doesn't see certain concepts, if it doesn't see subgroups that exist in the population, it's not going to understand that. Another key piece is user specifications. So users need to input something into this system that's been trained on all of this data to be able to get out what they want, hopefully. And underlying the machinery of these algorithms is typically deep learning architectures. So something called transfer learning, also stable diffusion, and a lot of other algorithms have been developed within deep learning to basically be able to generalize the patterns from the training sample, figure out some of these frequencies, and parse what the user specifies into what it knows about the training data and what's likely to come out of a request like that. So let's go into an example here. GPT from OpenAI is probably one of the better known ones, but there are a lot of open source models on Hugging Face, as well as a newer model called Llama that came out recently that can also do these type of tasks. So pre-trained transformer models, basically the algorithm is trained on this data. There's a network that's already been trained, and you simply have to give it the input to be able to get something out of it. You're loading in a model that somebody already created. And with GPT, this will give sequence to sequence decoders. It has a longer range memory to be able to kind of store the text that's come before as it's generating the answer that you want. So it can remember the last sentence. It can remember the context given what you've input. And it's already kind of blurring the lines between human composition and AI. So on the top, we have a haiku that I wrote, and on the bottom, we have one that GPT wrote with the instructions I gave it to create haiku. And there are a few tools that should work anywhere you are in the world. We're going to look at one of the older versions of GPT, GPT-2, which is available through an interface. I believe you'll have this presentation afterwards. So if you want to play around with GPT-2, just follow this link. I also added speech generation and image generation in case you want to play around with open source tools there too. So let's go to the link. And if you scroll down enough, you'll see this text generation demo. This one's using Falcon 7 billion, which is one of the models. I think there's a way to switch it to go back to GPT-2, but they tend to switch these models to showcase what's new. So let's put something in here. Write a sentence about customer satisfaction. So let's see what it comes up with. So we don't get a lot out of here. If you use one of the Hugging Face interfaces, so up here we have a way to import this into Python. You'll need to have an account to do that usually. So some of these you can just get, some of these you need to actually have an account for. But this one, you can just load into Python and generate what you want to generate. Again, this is one of the smaller models, and depending on which model you pick, you'll get better or worse answers, longer or shorter answers based on the model and some of the parameters that you give it. But this is a way to kind of play around with generative AI within the text context of being able to generate some of your own data. Particularly if you already have some examples, you can play around with the prompts and try to see if you can generate data like the text data that you have. Let's return to NLP and some of the things that you can do with it once you have text generated. So a couple common tasks are sentiment analysis and text classifiers. Sentiment analysis is pretty common in industry these days. Oftentimes with text data like customer feedback or chatbot conversations or even medical text, we want to understand the tone of the text data, if it's something positive, if it's something negative, or if it's something neutral. In recent years, this has expanded to other emotions. So a lot of the core emotions can be scored with some of these more advanced sentiment analysis tools to figure out if somebody's surprised or sad, angry, joyful, a lot of these primary emotions. So one of the caveats with this is that packages exist for some languages and emotions, but they don't exist for all of them, which is an interesting part of the NLP field right now, trying to get some of these NLP tools for other languages. Essentially, what you would need to do for that is to have a list of words and then some sort of platform or people who are willing to manually score what they think of with a given set of emotions for each word that you give them. It can take a while to compile, but once you have that, it's pretty easy to loop through that dictionary and score the text that you have. That's essentially what a lot of these sentiment analysis packages in Python are doing with English. There's a dictionary coupled to emotions, and it's just running through the text sample you give it and scoring that. Classification is another huge task. We can look at surgical outcomes based on physician notes. So things that surgeons might be noticing when they're prepping for surgery, or in some of the images, the notes that they have, some of the conversations they've had with patients. Also, you can look at types of customer complaints from automated feedback forms, which is the example that we'll look at with some Python code coming up. So you can look at perhaps if it's a service issue or a product issue, which can be really helpful to be able to automatically classify that and route it to the right department after you collect the feedback from customers. In addition, chatbots are huge these days, and being able to route conversations based on interactions with the chatbot and be able to escalate things. So when I was building an educational chatbot, we had a classification flag to be able to route conversations to a live agent rather than have the chatbot deal with it for some of the more severe things or people who aren't getting help from the chatbot. So classification can be really useful even within some of these conversational agents. However, there are a lot of difficulties wrangling text data into the numeric matrix that machine learning algorithms like so much. One of the first ways of doing this is looking at document word counts and frequencies. So you can either count how many times a word occurs in each document. You can do a binary measurement of whether the word exists or not, or some sort of weighted frequency, inverse frequency type matrix. However, these are very sparse, and that can be a problem. A lot of machine learning methods don't really like sparse, and it can take a lot to store non-sparse matrix. It can take a lot to store the sparse matrices versus something that's denser. So there are a few ways that we can go about doing this. The first is looking at embeddings. So the basic idea of embeddings is that you have this high dimensional data, these sparse embeddings, and we want to map it to a low dimensional space. We could use something like PCA or MDS or one of these dimensionality reduction algorithms. However, we only have the words. We don't have the context. We don't have the meaning. So pre-trained autoencoder decoder neural networks, not our generative AI tools, but different types of these, are able to capture some of the context. So consider the semantics of she bolted the door shut versus she bolted out the door. If the person is going out the door, it's very different than locking the door. And we want to have some sort of embedding that can understand this context. And these pre-trained models offer a way to do that. Some of the most common ones are the BERT and Roberta models, which are on Hugging Face. These are pre-trained neural networks that you'll load into Python. They have a good context for English. They can understand fairly complex sentences. They can understand fantasy type text. They can understand trademark words. And for some of the models that exist on Hugging Face, they've been trained on domain specific data. So some of these models can understand legal or medical terms fairly well to be able to help you if you have one of those jargon heavy fields. And these are pretty easy to use in Python. You load in the model and you just run it through the text. We'll see this in a little bit. However, these are very large models generally, and they require computer storage space. So my co-author and I were working on one of these models together, and it was hard for him to load it onto a different device than the one that I have that has more memory storage. So beware when you're using this. If you have a laptop, you're probably okay, but if you're trying this on a smartphone or on a tablet, you may not have enough memory to load this in, and you'll end up getting an error in Python. So let's move on to Python and see an actual example. So I generated some customer feedback, these comments, and the type of feedback, which is either the product itself or the services for a grocery store. We can see an example here of a product related issue of overripe bananas versus a clerk being rude at the checkout line. So let's dive into some of the code and see if we can classify this type of feedback and understand some of the sentiments that customers are expressing. I think you'll get this after the talk. For now, feel free to just kind of look here and then dive into it when you have the code. The first thing that we'll need to do is install 2 packages. This one is the sentiment analysis package, and this has our BERT model. So I'll run this. It can take a little bit to install depending on your machine. So that's run. Let's go into the sentiment analysis. We're going to use Pandas and OS to load in our data, and NLTK is a great NLP package. It's going to help us do some of the data processing. So we've loaded those in. This is our data set. This is where it lives on my computer. You should have access to the data set after this, but we'll load it in and then we'll run this. We have our 30 different customer feedback examples, and we'll score them with this and our collects function to be able to score the emotions and then append them to this vector up here. So we'll do that, and then we can look at a few of these to see which emotions are coming out and how things are being scored. So the output that you'll get is different core emotions and how the sentence is scored on this. So let's look at one of the ones that when I was data mining looked like a failed sentiment analysis here. So this feedback was they were out of my favorite kale. And I think what was triggering this was the word favorite. This is one of the weird things that can happen. You have fairly neutral words, and then you have a really positive or negative word, but the context isn't there. So these type of tools generally go word by word or token by token, and they're not always great at understanding the context. However, with longer examples of text, like if somebody wrote a paragraph about why they were unhappy with something, we would get better sentiment scoring out of this. But in general, it's a pretty good first pass of positive and negative emotion traits. Let's move on to classification of the complaint type. So classification is a little bit more complicated. We're going to need to do a little bit of pre-processing with the data, especially before we put it into the sentence transformer. And then we're going to create a machine learning model based on the embeddings that we get from the sentence transformer. So we'll load in the packages here. And one of the things that is really common with text data is to have missing data. And that's something that these sentence transformer models can't handle because we're not embedding anything. So I usually just go with a period. You can fill it in with any type of symbol that you might want, and it'll essentially ignore that line. But you need to have that in, otherwise you'll get an error with it. So we can fill in the comments in our data, and then we can run our model. So there are a lot of different BERT models and Roberta models out there. There are some that are multilingual. There are some that are just in English. There are some that do embeddings with different numbers of dimensions. So some of them are smaller embedding spaces, so it might only be 300 in the vector versus some that are over 1,000 dimensions in the vector space. So really, it depends on what you're doing. So if you want compact storage, there are some models that have exactly the same training data set, but they give a lower dimensional output, which might be easier for storage if you have really big data, versus some of these that might have 1,200 dimensions in them. That may be useful if you have smaller data and you want a little bit more information stored in those vectors. In general, the performance usually has more to do with the training data than the number of dimensions. And the training data can vary quite a bit, especially by language. A lot of the training data is scraped from online sources, and the quality can vary a lot by language and by the source that's scraped. And we'll see how this happens now that some of the sources that are really common in scraping want people to pay for scraping that data or have blocks for the scrapers. So definitely check out a few different models when you're doing this for a real problem, because different models are going to give you different performance. So it's best to kind of split your data so that you can play around with models first before you actually train the system that you want to use. So first we can load this in, and then we can strip the text to just get the text piece of our data set to input into our BERT model, and then we can encode it. One thing to be aware of here, this piece requires a lot of memory, and the encoding can take a lot of time if you have really big data sets. So definitely check the size of your data set. If it's more than 20 or 30,000, you probably don't want to do it on your laptop. You want to do it on the cloud, just because it's going to take a lot of time and memory on your machine. So we can do that step. In this case, it goes fairly quickly. We have really short sentences, and we have a really small data set. Because this is just a sentence version of BERT, if you have larger text, you're going to need to break it down into sentences first before you apply BERT, this sentence BERT to it. There are some that can handle whole documents, and there are some that are just word-based embeddings. In general, I found that sentence embeddings tend to work best. Now that we have our embedding, we need to wrangle it with NumPy to get it into a shape that's going to work well in our machine learning pipeline. That's a big part of text data analysis. There's a lot of processing that usually needs to be done to either clean the text first or to clean the output of some of these embedding models. So we can do that. And then we can clean this a bit so that we have our different parts for our model. And then we can create our test train split. So this is one of the handy functions in scikit-learn. It will randomly split your data into a training set and a test set for your independent variables and your dependent variables based on the random state that you give it, how you want it to be split, and the size, the relative size of each. So here we're going to do 80% in our training sample and 20% in our test sample. So we can run that. We have our array as our factors trying to predict this feedback type, and this will split it and give us our train and test set for our X's and our Y's. So we can run that, and then we can select a machine learning model. I tend to like going with a logistic regression or some sort of lasso or penalized regression model first. In general, having insight into kind of how the model is behaving can be good. Because this is an embedding space, something like random forests or a deep learning model might also work well to just get the prediction. With text data, often it's really just getting this prediction and being able to ensure that things are being routed correctly in the system or tagged correctly if this is going into a database system that needs some sort of tagging, like which department it should go to, etc. So we can run this, and the scoring is going to give us the accuracy measure for this. And for this model, we have 100% accuracy in practice. That probably means that there's something wrong. But again, this was generated data, and it makes a little bit more sense since it was generated to have very different features. But in practice, you can get pretty high accuracies with these embedding models. On real world problems, I've gotten a good 99% accuracy on some types of problems with a really good embedding. So if you're working with English and you try out a few of the more common embeddings on Hugging Face, you can probably get pretty good accuracy for the problem that you have if you have good training data and good labels being fed into these models. So we'll return here and go into a few of the ethical considerations when building these types of models. So there's a lot of things that have come up, especially in the last couple of months with GPT and the wide adoption of generative AI and more of these NLP tools. So as I mentioned before, training data is really important for these pre-trained embeddings and these pre-trained encoder decoder models. If the training data has bias in it against certain groups of people, or just missing important pieces of information, so if it doesn't see anything legal and you try using it for legal, it's not going to work very well. There's also been a lot of misuse of generative AI. A few months ago, there were issues with the stock market after there was a fake attack reported. And fake news is a big concern with generative AI and some of these NLP tools. As they've gotten a lot better at generating data, there's a lot of potential for misuse there. There's also the issue of representation in models, similar to the training data bias. If it doesn't see something, if it doesn't have a group of people who are represented or a language represented, it's not going to be able to understand that. And one of the things that I've noticed in practice with these multilingual models is that the quality varies a lot by language. So some of these models that can do dozens of languages or hundreds of languages, oftentimes it's really concentrated with English, Spanish, Mandarin, rather than even some of these widely spoken languages like Arabic. So be aware, if you know that you have a multilingual data set, that your accuracy may not be as high with some of these other languages in your data set relative to English. Misclassification biases are always a problem, so check your model and make sure that things look right. If you've got accuracies that make sense given your data, it's probably working better, but be aware if there are subgroups that are being misclassified or important text qualities that are being misclassified by your model. And then recently there was an article about plagiarism bias against non-native English speakers. So a lot of these AI checkers, because generative AI is based on these frequency models and non-native English speakers tend to learn the more common idioms, the more common ways of phrasing things, oftentimes these plagiarism detection systems are netting non-native English speakers as false positives for AI generated content. So just be aware of that. And I think as we get into the questions, some thoughts and discussion about some of these ethical considerations is definitely worth having, because as we build these systems and use these technologies, we need to make sure that they're being used fairly.
Thank you, Colleen. This has been wonderful. I know everyone has been talking about Gen AI since the day it has been launched. It's everywhere, and everyone wants to adapt it. So thank you so much for shedding light on the ethical aspects as well, which are very sensitive. And I think we generally overlook those considerations before we plug the latest and the greatest technologies into our systems. So talking about ethical considerations, I know you already mentioned, and I love the slide that you showed. There is a question from the team out there. They say, love that you discussed ethics and biases. Do you see generative AI being used towards the dream of more pay, less work, or more gain for capitalism contributing to more layoffs? That's a very, very tough question.
Yeah, and I can see both sides of the coin. It really depends on the people. I would say that leaders of countries and companies have the ethical responsibility of figuring out what to do with displaced workers. I have a feeling that it's going to reduce staff in a lot of areas, unfortunately. Ideally, I think humans combined with AI are a powerful combination and probably the best for both workers and for companies making money. People can be more productive when these technologies are a little bit further down the line and more reliable. Right now, it's a lot of questionable stuff coming out of models and more time being spent fact checking or debugging code coming out of this than it would take for somebody to actually do the work. But I think in the future, ideally, people having access to these tools and working with AI is going to be really powerful. But like any new technology, it really has the potential for misuse. And I'm seeing a lot of things across industries of let's lay everybody off, try to replace everyone with AI, and then, oh, this doesn't work. There was actually a mental health application that had to pull their bot when they got rid of their human workers and let the bot run everything. It went rogue and started giving really harmful health advice to people seeking help on their site. And I think there's a huge potential for that type of misuse relative to kind of taking this slowly and seeing what can be done and these safety issues that might come up with technology not really going rogue in the sense of general AI, but they're not sentient. And we have to be cognizant that they're not sentient. They don't know what they're doing and they don't understand how they might impact humans.
Absolutely. I mean, that's a wonderful way to put it. We need to be really cautious about how we are plugging it in, and the interpretation of the data that's been provided by the model also needs to be, like reviewed before we blindly follow that.
Exactly.
All right, I have another question for you. So what are some of the ethical considerations you've already encountered related to Gen AI, and what are some that you foresee might come up in the near future?
So with the educational bot from a couple of years ago, before we had generative AI in it, we were already seeing people reporting things that had happened that needed to be escalated to a human. So safety concerns of students, reports of cheating, those sorts of things. We needed to find a flagging system to be able to escalate things to humans. And I think with generative AI and more of these bots out there, there's more of the potential. A lot of the social science research about human bot interactions suggests that people are more open with bots than they are when they know that they have a live agent, or when they're face to face with somebody, that they're more likely to disclose these sensitive things. And we need to be aware of that when we're designing these systems and have a way to escalate. Also, personally, I've had a lot of trouble with some automated systems understanding my accent to say, get help with a credit card issue. And we need to be aware that these things can fail and have a fail safe that goes to a human. I think that's really important.
Totally. All right. Well, I have a next question. It seems like respondents' comfort with the language they're using could be a really important aspect for the performance of bot. For example, if they are responding in English, but it's not their primary language. Is that accurate, or would you put it in a different way?
To some extent, it definitely does not work as well for non-native English speakers using English trained systems. However, a lot of them are pretty good at figuring out context and how things might be phrased. A lot of the training for these embeddings, at least, is from Reddit, which has non-native English speakers on there and has some examples of how somebody learning English might phrase something versus a native English speaker who understands the idioms or certain linguistic nuances. So they can mitigate that to some extent, but it's definitely not as good. And that's one of the ethical considerations. There are essays being flagged unfairly because someone is a non-native English speaker. So it's important to test those systems. And I would suggest if you're putting something into the wild with customers, especially medicine, law, education, anything that has a high potential for harm, definitely make sure that it's tested by somebody who's a non-native English speaker to see if there's any blind spots.
Absolutely. Right. So the next question is, for folks interested in using NLP for social science research, do you have any recommendations for how to design survey questions to improve the results?
Yeah, open-ended questions tend to be great, especially if they're coupled with some of these forced choice or list type questions to collect enough information to parse it. So when I'm doing social science studies, I tend to look at some of the demographic factors and collect those more of the traditional way, and then have something open-ended where NLP can be used to derive sentiment, to figure out word choices, kind of whatever you want to study. There's probably a tool, especially in NLTK. There's a tool for almost everything these days in there. And if not, with some of these embeddings, if you have a human scoring thing, so a lot of times there will be a grad student or undergrad kind of scoring the text manually from their experience rather than just all one system. And I think there's a good synergy there, but definitely open-ended, letting the human really be able to respond to your questions. It's not as big of a deal with these open-ended questions as these yes/no type things. People will kind of write based on their experience. And I would say have a couple of people read over the question first and make sure that they all understand it the same way. So kind of a pilot study, or everyone in the lab kind of looking through the question and answering it the way that somebody responding to the survey might answer it should give you a good idea of whether or not the tools will work.
Absolutely. I have one quick question then. So I know prompt engineering is coming up because Gen AI is taking the front row in every discussion. Would you say the way we frame a question also induces a lot of bias when we are like retrieving the data? On what precautions would you throw out there for someone who's like trying to adapt, Gen AI into their workspace?
Yeah, I would say be careful. Different models respond to the same prompt differently. That's something I've gone through this week. When you switch things out, things can break. And I would say try out a few different prompts when you're working with this and see what works best with the system that you're using. They understand things very differently than humans. They really are stochastic parrots. They're not understanding the context of what you're saying unless it's something that they've seen that context before. So definitely try out a few different prompts. I found some that work well across language models or across image generation models. But as things are updated, your prompts are going to break and you're going to have to rewrite those prompts and figure out all of those nuances again. It's kind of annoying, but these are neural networks and we have no idea how these connections are working when there are billions of them. So it's really trial and error at this point and kind of getting a knack for what seems to work across lots of different platforms or lots of different model iterations that you're doing.
Totally. So for beginners who are like just breaking into the Gen AI space, trying to understand how and when should we even move to Gen AI, what recommendations would you give them? Any resources that you would recommend them to start from?
It's great for synthetic data. If you can learn enough and kind of play around with the tools to see what kind of data you can generate, it can be really useful in that context. With bots, a lot of them are fairly easy to set up with like OpenAI and fairly low cost with OpenAI these days. But a lot of the open source models, they're very finicky and you're going to need to do a lot of engineering to get something usable out of them. These interfaces of interact with our models, there's a lot of engineering behind them that you're not going to get with your API. So I would suggest kind of playing around with the simple models first and then kind of going into more of the building.
Absolutely. I have one last question before we wrap this up. We have a lot of these models come up from Microsoft is coming and releasing one. There's Google coming up and producing one. There's Amazon coming up with one. So you have so many models that you can pick from, so many pre-trained models. So do you have any specific use case that you would go to one model versus the other?
Yeah, it really depends on what you're trying to do. So conversational agents are really different than text summary agents, and some models are really good at text summary, but not great at conversing with you. And it's really just getting a feel for different models and what they do and what they don't do. I found that with image generation as well. Some of these models, they really don't understand the context of certain animals you might want to create or certain ethnicities or regions of the world, but other ones do. Again, it mostly comes down to training data. What the model has seen is what the model is going to do. And right now, it's really the wild west of generative AI. It's hard to know what's in a model, and it's hard to know where a model might go in the future. Every day, there are new generative AI models coming up. There are new language embeddings coming up. And it's kind of the wild west and figuring it out as you go and kind of getting a knack for a few models that seem to work well consistently. I think it'll get better in the next couple of years, but it really is the Wild West right now.
Yeah. Yeah, there's something or the other that's new that's coming up and it's catering to different things. So we just need to understand the right thing.
Exactly.
Okay, we have one more question in the chat, if that's okay.
Yeah.
Do you think causal inference can help the research in understanding performances of different LLMs? To be precise, we have seen that ChatGPT-4 is not performing as expected. Do you think causal inference will help with understanding and explain why this is happening?
It may. I think a lot more of it with a lot of these models that you can interact with have feedback mechanisms. And I think that's a lot of what we're seeing. People are interacting with these, it's learning from the people. And unfortunately, we have a lot of bad actors out there, so they can teach the model bad things or incorrect things or just kind of try to see if they can break it, and it's getting incorporated back into models.
Yeah. All right. I think that's all we have for today. Thank you so much, Colleen. This was wonderful. We learned a lot. And like you said, there are so many things that you need to carefully think before you depend on the results, and you put so much thought into it and plug it in. So we learned a lot. Thank you so much. This was amazing.